The last example from divergence theorem. So again we are going to use divergence theorem to calculate the flux integral over a closed surface S. Now this time our vector field F equals to xy squared comma x squared y comma y, and then S is the surface of the closed cylinder defined using these two inequalities. So we have the boundary of this cylinder equals to x squared plus y squared equals to 1, and then this is a closed cylinder and the top surface is given by c equals to 1, the bottom surface of the cylinder equals to c equals to -1. Now here is the picture of the domain. Now here we have a closed surface, therefore the region enclosed by this closed surface is a three-dimensional region. Let's say your 3D region is E. Then when we apply the divergence theorem, of course as always we need to calculate this quantity, divergence of F. So now let's calculate the divergence. Divergence of F equals to partial over partial f x of xy squared plus partial derivative of x squared y with respect to the y variable, and finally partial derivative of y with respect to the c variable. This will give you the divergence of F. So basically the first one is y squared plus x squared plus derivative of y with respect to the c variable is 0. So now your integrand is y squared plus x squared. Since my domain is a cylinder and here I see the term x squared plus y squared, so this time we are going to use cylindrical coordinate system to evaluate this triple integral. So using cylindrical coordinate system, we get this triple integral equals to, of course x squared plus y squared is r squared. The volume element dv is r dc dr d theta. Your c values goes from -1 to +1. Since our cylinder is x squared plus y squared equals to 1, the radius of the cylinder is 1, therefore r goes from 0 to 1. We have the full cylinder, hence theta goes from 0 to 2 pi. My first variable of integration is z. So with respect to the c variable, this term r cubed can be treated as if it is a constant, and if we integrate r cubed, you will get r cubed times c. Lower limit is -1 and upper limit is 1. Apply the upper limit first, you will get 1 minus r cubed times 1 minus -1. One minus -1 becomes 1 plus 1, which is 2. We can pull out a constant from the integral sign. The integral of r cube with respect to the r variable will give us r to the power 4 over 4 Now apply the upper limit, you will get 1/4 minus the lower limit results 0. So now we have 2/4 times the integral of 1 d theta, which is 1/2 times theta. Integral of 1 with respect to the theta variable is theta. Lower limit of theta is 0, upper limit is 2 pi, and if you apply the upper limit, you should get 2 pi minus 0, which equals to pi. Great. So with this we finished chapter 13.7.